In the last lecture, we talked a lot about right triangle trigonometry. So finding missing sides and missing angles in a right triangle. Now we're going to take the right triangle and we're going to convert the ideas into a circle. Okay, so we're taking trigonometry and we're looking at it from a very different perspective. And what we do is we start off by looking at something called the unit circle. Okay, so first of all, let's talk about what a circle is. Okay, I don't know if you ever really defined a circle or if you can come up with a definition for a circle, but essentially what you have is you have a single point. That would be your center point. Okay, this is your center of your circle. And then the circle is constructed by taking a distance, a fixed distance, which we call the radius, and every point that is that distance from the circle, from the center, would be on your circle. So up at the top here, this point over here is a fixed distance. It's r, okay, from the center. Now this point is the same distance from the center. We could take a point over here and this would be the same distance from the center. We could take a point over here and it would be the same distance from the center. So we could keep doing this, and if we connect all of the points that are that distance from the center, so this is not the best circle, but if we take all of those points, we get a circle, okay? So a circle, the way that we would define it, it would be all points that are a fixed distance r from a single point. Okay, that r is your radius. And this single point here is the center of your circle. Okay, now the way that we distinguish between circles, there are two ways that we distinguish between, let's say, this circle, which I apologize looks more like an oval. I promise you on my paper it looks more like a circle than it does here, okay? But we have two ways of distinguishing between, let's say, this circle and another circle, okay? So if I have a circle here, and then I have a circle over here, the question is, how do we distinguish between these two circles? What makes them different from each other? So we know that they're the same distance from the center, right? They're all the points the same distance from the center. That would be the definition of a circle. But what makes this circle 1 and this circle 2? What makes these circles different? Okay, so there are two things that make two circles different from each other. The first thing is obviously the size. Okay, so this circle is smaller than this one. So size is one thing that distinguishes between them. The second thing is the location, right? So we could have two circles, they could be the exact same size, but they're located in different places. Maybe this circle is over here on the page, and maybe we have another circle the exact same size, but it's over here, okay? So we distinguish between circles using size and using location. So how do we measure the size? We measure the radius. And how do we identify the location? By where the center is. Okay, this is how we distinguish one circle from another. So let's consider something called the unit circle. So the unit circle is on the coordinate plane. The coordinate plane just means the x and y axes, okay, as opposed to, let's say, the complex plane where our axes are complex and real, okay? So the unit circle is on the coordinate plane, and its size, or the radius, is equal to 1, and its location on the coordinate plane, or its center, is at the origin. It's at 0, 0. So in other words, if we were to draw this circle, and don't worry, I'm going to show you an accurate version of the circle as well. So here is our XY axis. And the way that we would construct this circle is its center is at 0, 0, so we're starting at 0, 0, and its radius is 1. So what that's doing is it's saying every point is exactly 1 unit from the center. So the easiest way to do this is to construct the 4 points that are on the axes, because we know what those are, okay? So if we go to the left by 1 unit, then we are at the point 1, 0. If we go up 1 unit, then we're at the point 0, 1. If we go to the left 1 unit, we're at the point -1, 0. And if we go down 1 unit, we're at the point, we're probably over here, we're at the point 0, -1. And then we're going to roughly connect these. I think the more accurate point would be here, probably. Sorry about that. I will show you a nice, accurate version of this. Okay, and if we keep going, okay, this would be our unit circle. So what does it look like when it's drawn well? It looks like this, okay? Ignore the yellow boxes for right now. It looks like this, right? Here's a nice, beautiful circle. We have our 4 points. Our distance, our radius is 1, okay? Our radius is 1, and our center is at the origin. So this is our unit circle. And let's see if I could. I'm just going to do it this way. Ignore me. Here we have our unit circle. Okay, our radius is 1, and our radius is 1, and our center is at 0, 0. Okay? Okay, so what do we know about this unit circle? So first of all, it is a graph, okay? So it does have an equation. So let's figure out what this equation is. So an equation of a circle is a relationship between our x and our y, okay? So let's say, for example, that we have a point x comma y. It's anywhere on the circle. Let's make it over here. Okay, that point right there is the point x comma y. And we need to figure out some sort of relationship between our x value and our y value. So in order to figure out this relationship, we can create a right triangle. Okay, so let's do that. So to do this, we're going to draw a line that comes from the origin and it hits this point. Okay, let's make this a little bit thicker so it's easy to see. Okay, so we have this, and then we can actually drop a line as well to the x-axis, and we could do this anywhere on the circle. We can always drop a line to the x-axis. Okay, and we'll make that a little bit thicker also. Okay, so we have a right triangle here. And we know something else. We know what this distance here is equal to. Because if this is equal to x, okay, then this distance here is equal to x. So let's put that in there. This distance is equal to x. And if this distance from here to here is equal to x, then this distance, this vertical distance, is equal to y. So over here, this is equal to y. Okay. Now we know something else. We know what the length of this line is. The length of this line is 1. Because it's the unit circle, this is the radius. This has a length of 1. So no matter where we draw our triangle, this is going to be true. We could draw it over here. We could draw it down here as well. Okay, if we drew a triangle down here, the horizontal distance would be x, the vertical distance would be y, and the diagonal would be 1. And we can come up with a relationship between x and y then, okay? And the relationship is the Pythagorean theorem, okay? So the Pythagorean theorem says a squared plus b squared is equal to c squared. So here's the thing though, right? This is similar to what we were doing when we were trying to identify like all of the different 6 trig functions given one trig function. So you were given the sine of 3/7 and we wanted to know what the cosine was, what the tangent was, cotangent, cosecant, and so forth. Instead of labeling this a squared plus b squared equals c squared, or even opposite squared plus adjacent squared over equals hypotenuse squared, we can use this x squared plus y squared is equal to 1 squared. Okay, or we could be even more general and say x squared plus y squared is equal to r squared this is the equation for any circle with center at 0, 0. But if we want specifically the equation for the unit circle, the equation for the unit circle would be x squared plus y squared is equal to 1. Okay, that's the equation for the unit circle. And just to note that let's say that our center were at 2, 3. Well, if our center is at 2, 3, essentially what we did is we're translating the circle 2 units to the right, and we're also translating it 2 units up. So we would put that transformation inside here. Okay, so let's write that down. We're going to write all of this down. And I'm going to put it into the board notes too because I can include this as a separate file, but I also want it sort of inside here. Okay, so here's what we're going to do. I'm going to make a bigger picture of this. It's not going to be perfect, but you have the idea from the other circle that's there. There's some people who just draw circles so well. So here's our this was not that accurate. Okay, but hopefully you have a pretty good idea. This is awful. Let me see if I can fix it. I think this point has to come here. At least I don't have to see your faces as to how awful this circle looks. Okay, so here's our x and our y. So equation of a circle is x squared plus y squared is equal to r squared. That's because if we take any point x comma y and we create a triangle, a right triangle, and we're going to be doing a lot with right triangles inside circles. This horizontal distance is x, this vertical distance is y, and the diagonal is r. So we're using the Pythagorean theorem to create a relationship between x and y. Okay. But if we want the equation of the unit circle, then in that case, we have x squared plus y squared is equal to 1. Okay. Now this has, just as a side note, okay, this has a center of 0, 0. But not every circle has a center of 0, 0, right? Let's say that our center was at C comma D, okay? What that's doing is it's moving it to the right by C and up by D, okay? If we have our center at 2 comma 3, we're going to the right by 2 and up 3. That's a translation, okay? So when we move our center, we're translating it. So if the center we're at 2 comma 3, and if you notice I'm not putting this under the unit circle, that's because the unit circle specifically has a center of 0, 0, okay? But if the center of your circle were at 2 comma 3, then the equation well, when we go to the right by 3, we subtract. Sorry, to the right by 2, we subtract. And it turns out that what we're doing to y, well, y is on this side of the equation now, okay? What are we doing to y? We would typically take the whole equation and we would add 3 to it, right? But now we're on the other side. Now it's not, we don't have f of x equals x, and then we're adding 3 to the x. We're adding 3 to, we're doing something to the other side of the equation, okay? So if we had, just as a side note, I'm putting it down here, just so that you understand what I'm saying. If we have f of x is equal to x squared, this is like y equals x squared. So if we go up 3, it would be y equals x squared plus 3. On the other side of the equation, we could move it to the other side and make it y minus 3 equals x squared. So notice what's happening here. What we're really saying is happening is that, yes, we're adding 3 to the whole function when we go up. But what's happening to this y value over here when we're on the other side of the function? We actually subtract. So when we talk about circles, we do the opposite for both of them. So we do the opposite for the 2, it becomes x minus 2, and the same thing is true for the 3, it becomes y minus 3. And this is equal to r squared. And if the center were at, let's say, c comma d, then the equation would be sorry about that. The equation would be x minus c squared plus y minus d squared is equal to r squared. And again, it has to do with what side of the equation we're on. So we're affecting not what y is equal to like we are here, we're affecting the actual y. Okay, the individual y, so it would be y minus d. So this is just a side note that if your center is not at 0, 0, what you're doing is you're translating your function, okay? And here's the translation. We go a minus c and a minus d. So the equation of the unit circle, that's not applicable though, because the center is at 0, 0. And our radius is 1. Okay, we could even say something a little bit more here. So I'm going to change this r to a 1, or I'll just write it as r equals 1. Okay, so we could take this even a little further with this triangle. We could say, okay, well, in this triangle, r is equal to 1. Let's say that this angle here is theta. Now, if that angle is theta, then we could take this one step further and we could figure out what the sine of theta is and what the cosine of theta is. So the sine of theta, so this is again in the unit circle. This only applies in the unit circle. the sine of theta is our opposite over a hypotenuse, okay? And if we label this triangle based upon this theta, okay, so we have our right triangle, and based upon the theta, we're going to label opposite, adjacent, and hypotenuse. So the y is the opposite, the x is the adjacent, and the r is the hypotenuse. So what does that mean? The sine of theta is equal to O over H. Our O is y, and our H is 1. So the sine of theta is y. Now we could do the cosine of theta. Cosine of theta is A over H. And in this triangle, A is equal to our x, H is equal to 1, so our cosine is x. Okay, why is this important? So when we travel, we can actually travel around a unit circle, okay? So we can travel around any circle on an axis, okay? Let's just take one step back before we do that and make sure that everybody is on the same page here in terms of this unit circle, okay? Because I gave you a lot of information and I just want to summarize it so that you see that it's not complex information, okay? Unit circle is a circle with a center at 0, 0 and a radius of 1. What's the equation for that? It's x squared plus y squared equals 1. Okay, how did we get that? It's just the Pythagorean theorem. We take any point x comma y on the unit circle, and we create this right triangle where the horizontal distance is x. If we wanted to get to this point here from the center, from the origin, we go over x and we go up y, okay? So that means that we have x squared plus y squared is equal to 1. That's the Pythagorean theorem. Okay. Then we can also find the sine and the cosine of this angle here. So this angle is theta, and the sine is opposite over hypotenuse. So when we take this right triangle and we label the three sides, opposite, adjacent, and hypotenuse, the opposite side is y, and the hypotenuse side is 1. So the sine of theta is just equal to 1, is just equal to y. Now we can do the same thing for cosine. The adjacent side is x, the hypotenuse is 1, so the cosine of theta is x over 1, or just x. Okay, you'll see why that becomes important in a few minutes. Okay, when we travel around a circle, we travel counterclockwise, okay, the opposite of a clock. So we travel around the circle like this. Counterclockwise. We start here. Okay, we start at this point right here. That's our starting point. We also have quadrants, okay? And this is true of any graph, anything on the coordinate plane. This here is quadrant 1, because when we travel around the circle, this is the first quadrant that we go through. We start here. This is the first quadrant. We're going counterclockwise, so this is the second quadrant that we travel through. We can just use a Q. Notice we use Roman numerals. And then this would be the third quadrant that we travel through. And finally, we finish up in the fourth quadrant. Okay. Now, when we create an angle, this side of the angle, every angle is made up of two sides. So this side of the angle is called the initial side, and this side is called the terminal side. Now, we're going to get into that a lot more later, okay? Because we're not going to be looking at specific angles. But what we're saying is that any angle, the sine of that angle is y, and the cosine of that angle is x. So this is the same thing as saying, okay, well, whatever our x is equal to, that's the cosine. And whatever our y is equal to, that's the sine of that angle. So what does this mean? Okay, well, we start here. This is, so I'm going to label the coordinates, okay, the 4 coordinates. This is 1, 0. This is 0, 1. This is negative 1, 0. And this is 0, negative 1. Okay. Now we can also label this in terms of degrees. So when we start, how many degrees have we traveled? We've traveled 0 degrees. Now we keep walking around the circle. When we get to here, how many degrees have we traveled? We've traveled 90 degrees up here. Now we're going to keep walking. When we keep walking around here, how many degrees have we traveled? 180 degrees. Now we're going to keep going. How many degrees have we traveled when we get to here? This is another 90 degrees. So it's 270 degrees. And we keep going because we have to go all the way around. And once we go all the way around, we're at 360 degrees. Okay? So what does this mean? The fact that x comma y is the same thing as cosine theta sine theta. Okay? What this means is that 1 comma 0 tells us the sine of 0 degrees and the cosine of 0 degrees. Okay? The sine of 0 degrees is the y value, so it's 0. And the cosine of 0 degrees is the x value, so it's 1. So this here, let's do brown. This here is the y value at 0 degrees. And this here is the x value at 0 degrees. Okay, we could take this further. We can say that, okay, now we also know the sine of 90 and the cosine of 90. The sine of 90 is the y value, so it's 1. And the cosine of 90 is the x value, so it's 0. Okay? Here, we could say the sine of 180 is equal to 0, and the cosine of 180 is equal to 1. So we're looking at the y value at 180, and we're looking, sorry, this is negative 1. Let me rewrite that. So we're looking at the y value, which is the sine, and then the x value is the cosine. Again, we prove that here, down here. Okay, this is only true for the unit circle. Now we also know that the sine of 270 degrees is negative 1, because that's the y value, and the cosine of 270 degrees is 0. Again, because that's the x value, okay? And in fact, if we go back up here, we can also say the sine of 360 degrees is the same as the sine of 0, and the cosine of 360 degrees also the same as the cosine of 1, as the cosine of 0, okay? So notice what's happening here. Now we're not working within right triangles anymore, right? Because we're figuring it out based on the right triangle. But a right triangle doesn't have 180 degrees in it, okay? No triangle has 180 degrees in it. So now we're talking about bigger and bigger angles. Now we're going to do this more, but let's add this in to our much, much nicer triangle here. Let's add in the degrees, okay? So we know that this is 0 degrees, but it's also 360 degrees over here. I'll put this right here. Okay. And then over here, this is 90 degrees. Over here, this is 180 degrees. And over here, this is 270 degrees. Okay, so each of these has an angle, and let's put in our theta. I think I have it in here. Okay, so this angle right here is theta. Okay, and we're going to be working with this a tremendous amount. So again, we have quadrant 1, quadrant 2, quadrant 3, quadrant 4. We travel around the unit circle in a counterclockwise direction. Okay, always counterclockwise. So when we start over here, this is 0 degrees. As we travel, this is now 90 degrees. We keep traveling. This is now 180. Every quarter circle is 90 degrees. We keep going. This is 270 degrees. And if we go all the way back around, we're at 360 degrees. Okay. Now the sine of 0 degrees is the same thing as the y value here. So the sine of 0 is 0. The cosine of 0 is the same as the x value. So the cosine of 0 is 1. Okay, again, we showed that using the right triangle, that the sine of the angle is y over 1, which is y. The cosine of the angle is x over 1, which is x. The sine of 90 degrees is 1, and the cosine of 90 degrees is 0. The sine of 180 degrees is 0, and the cosine of 180 degrees is negative 1. Down here, the sine of 270 degrees is negative 1. And the cosine of 270 degrees is 0. And finally, when we come back to 360 degrees, the sine of 360 is 0, and the cosine of 360 is 1. Okay, so this is the unit circle and everything that you need to know about it, and then we're going to be working with this a tremendous amount in the next couple of lectures.